Welcome to the Whirlwind Introduction to Python. We're going to be going through how to get started in Python, some key concepts, and we're going to use Google Colab. So this will be in your browser, a link. You should be able to access a link. And what we're going to do is go through this quite fast. We're going to cover quite a lot of content, but it's a good starting point. If at any point you find yourself getting confused, there are resources to delve into some of the topics in more detail, which you can also do after. So as I mentioned, we're in Google Colab. This is just Google's online. I think of it as similar to use Python rather than having to install everything on your computer yourself. We're not going to focus too much on how Google Colab works. Today, we're going to focus more on the Python programming language. So just a little reminder, you can go through this. You don't have to run anything, but if you want to run or edit anything yourself, some things you can do is say File, save a copy in Drive, and then that's your own one that you can edit and you can add things to. You can also create your whole new notebook if you want to go through that. We have these code cells here. If you want to run them, you can press this button. You can also just follow through the notebook with me as I do this. So I think Python is a great coding language to learn. It's quite logical. I think how it's written is quite a simple language, simple English. There's not too much to wrap your head around. You can get started really fast, like in the browser. That's amazing. It can be used for website development, so databases and backends of websites. It's also used an awful lot in all things data, machine learning, and AI, which I believe is why it's so popular at the minute. This is aimed at people who have no coding experience. So I'm going to go through things very simply. If you're just looking to understand the syntax or the language of Python, this might be a good start. And if you've never coded before, this should also be fine for you. This will be Python 3. So if you have any experience with Python 2, there'll be some ever so slight differences. So let's start with writing some Python code. So one thing that I always start with is comments. So comments are a bit of code that don't actually do anything. So they're just there. Like if you're working on something together, or sometimes I use them to write notes to myself of things I want to do in the future. But in Python, how we do that is we just add a hashtag to the start of a line, and then that doesn't do anything. So when I run this, you can see in the corner here, it's connecting. It's connected now, yay. Nothing actually happens, so nothing is output. So if we actually want to output something, we can use this command called print. And something we often do when we're learning programming is say hello world, or we can print a number. So if I run this, you'll see it says hello world 123. But this line at the top that was a comment and started with a hashtag, nothing got printed out for it. I'm just going to draw your attention here to colors. So it's actually quite important in coding languages to pay attention to the colors of what you're typing in. You notice the comment turns green. So if, for example, I delete this, the green goes away. We can now see that there are red lines under it and it's telling me there's a problem. And if I put this hashtag back in, it goes green. Keywords tend to be in yellow, this light yellow here. So print is a keyword, like a reserved word. It's something to be done. Our brackets are darker yellow. Strings, so text in between quotation marks, is orange, and numbers are this very light green color. They are quite similar, some of these colors, but it's worthwhile paying attention. Again, if I delete this, we can now see that this bracket is unhappy and underlined. And if I close this bracket, then we have these new, all of them are yellow. Cool. So just pay attention. It might help you do some debugging or finding problems later on. And if you notice here, we had quotation marks and not quotation marks, which leads us nicely into data types. So to me, the basic data types in Python are string, numeric, and Boolean. Data types are important because different built-in functions can be used on different data types. So a string is any text. And how we count that is we use quotation marks. We can use single or double quotation marks as long as we use the same one at the start and the end. And in this Google Colab example, all strings are this weird orange-brown color. So for example, if I just delete this, and add the start one but not the end one, then we can see that this is a problem and it doesn't like it because it's saying that this quotation mark is not closed. So I can go back and do this. And when we print out, the quotation marks don't get printed. They're just there to indicate that this is a string. And yep, they can be quite long. You can take new lines, things like that. We can add strings together using this plus. So my name is Laura. If I run this, it'll print out my name is and Laura. Notice I added a little space here. If I didn't add the space, they'd just be smooshed together like this, which isn't very good to read. And yeah, if I click on the cell also, just you can hit Command or Control and Z and it'll go back to where it was before, just like undo is normally. So numeric, you might have guessed, is numbers. We have integers, which are whole numbers, no decimal places, so just like 1 to a million or anything in between. And then we have floats, which are a number that has a decimal place. And we are using decimal places as full stops as opposed to commas, which I know some countries use. So these look like this when they get printed out. Yeah, and we can do some operations, it's called, some mathematical operations on numbers, and these are basically adding, subtracting, multiplying, and dividing. So we can use the plus sign and the minus sign for adding and subtracting. We want to use the star, so the asterisk, for multiplying, and we want to use the / for dividing, and we can then also use this double star to say put something to the exponent or the power of. So if you know what squaring something is or multiplying something by itself, you would use * 2. So you can see here, these being output as every line but this fourth line is using integers. The output remains as an integer, but because this one is using a float, we also get a float out, a very long float out. So things can change between integers and floats when needed. So these are just numbers. You can see that they are a slightly different green color than the comments, but we can see when they're numbers. And the other data type I mentioned was Boolean, which is a very funny word, but to me it just means it's true or false, something that can have two values that we typically think of as 1 and 0. So we think of true as 1 and false as 0. And again, if you notice here, we have capital T, capital F, and it changes to blue. So if I was, for example, to do this, and then if I try to print this, it says true doesn't exist because it's not a Boolean. So I need to add the T back in just to make sure that it knows I'm saying true and false as actual Booleans. And we can have things called Boolean statements. So that's when we're checking if something is true or false. So here we can use two equal signs, so equals equals, to check if two things are equal to each other. So here we have 4 equals 7, which we know to be false. And here we have the numeric 4 equals the string 4. So notice how they're different. And they are not equal. So something worth noting. We can say not equal to by using exclamation mark equals, less than or equal to, greater than or equal to. And yep, we can get out a true or a false statement based on all of these. So far, we have been talking about something that we call literals. So all of these data types, we've given a literal value. So we have 4, we have the words hello world, we have true. They don't change. They are literally what we tell them. They are literally what they are. But we have these other data types called variables. And as the name suggests, these can vary and these can change. And how we use them is we use a word or something with or a set of letters or with it can be, we can also add in like underscores. So we could say name of player if we want to. I'm just going to undo that. But we have the name and then of the variable, and then we have a single equal sign. So notice that's a little bit different than up here when we had the double equal sign. How we explain this is double equals is a comparison, so to check if they're the same, and single equals is to give something a value. So we call it an assignment operator. So here we have the name is James, and we have height 1.5, and if they're a student, true. So these are all variables we can now run, and I can print the variable and it will print James. It's important that we use the case, these are case sensitive. So if I now say name, it's going to say that variable doesn't exist. So I can also change this name to be, let's change it to Jamie, just for the sake of it. Oh, and I can't spell. So now we can click run. We can run it again and it'll print out Jamie. Yeah, and again we've got test here which hasn't been defined, so if I try to run it, it's going to say name test is not defined. So if you get a name error in Python, check you spelled everything properly and check that you've actually assigned it somewhere. So some more printing. So we've got item, number of items, and the amount. So this is something worth noting, is we can actually set variables equal to the value of other variables. They don't automatically update unless you run some code after. So if I run this, and if I rerun amount at any time, it'll update it. The print here we have is total amount in pounds equals amount. And what I've just done is use this to combine the two, so the comma in between. So we've combined this as a string. And here we've got your currency and the total amount. And let me just show you what I was trying to say earlier. So if I now make item equal to 10 and I run this code, we have amount is equal to item times number of items. So do you think it's going to be 50 or 45 whenever I run this bit of code here? And it's 45, because even though we updated item, we haven't actually updated amount yet. So we would need to run this bit of code again for it to update. So I can show you this here. And now if I run this again, it'll be 50. So it doesn't automatically update, even if you change the variables that it's based on. And just to talk through what I've done in this print statement, so you see here it says your total is £50. I've said your total is, and this is a string, and this is the decimal. And then I've put the percentage sign here and said the first variable you're going to sub in is currency, which we have set here. And the second variable you're going to sub in is amount, which is a decimal. And that's how we can do some interesting printing based on variables. We also sometimes might not know what the data type is. So we might want to actually print out what the data type is. So we can do that by saying, but we can use type. That's another built-in function. You can see it goes green here, and the brackets inside the brackets go pink. So we can print, and this is how it outputs. So we have class integer, class float, class string, class boolean, and then if we print the type of a variable, we don't actually get variable out, we get the type of what it is. So that if we remember, amount was 50, so that is an integer, which is interesting and useful. We can also move between different data types, which is something we call casting. So we can cast to a string, an int, a float, and a boolean, depending if the data can move in between. So if we have the variable 4, which is a number, and we print the type of 4, it prints out as an integer, but we can cast that as a string, and then that will print out 4. Even though it looks the same in the output, we can see that it's a string by now printing out cast of string 4. And we can use this whenever we're printing, so whenever we're putting things out, just to make sure that it actually gets copied to a string, and then we can use it in this concatenation, it's called, so pushing things together using these plus signs. Otherwise, it might try to add the number 4 to these letters, and that might not make any sense. So all numeric data, floats and integers, can be converted to a string. And strings of just numeric data, so of numbers and decimal places, can be converted from an integer or a float to a string. The integers 0 and 1 can be cast as Boolean, true and false, and true and false can be cast as strings and numbers, so they would be cast as 1 and 0. Just if this helps anybody wrap their head around it. Interestingly though, with Booleans, something to note is if we say Boolean true in quotation marks, it returns true. So that kind of looks like we can cast the string without the capital T into a Boolean. But then if we do it for false, we also get true. So how does that make sense? Because we'd be expecting it to be false in that case. And what actually it's checking is whether or not this is empty. So if we do a Boolean of an empty string, so just 2 quotation marks, it prints out a false. So just be careful that you understand what you can cast backwards and forwards, because it might be a bit confusing. Moving on to input statements. So I think input statements are really cool. They're quite interesting if you're building a game or a chatbot or trying to get a user to do something. And it does what it says in the tin. It asks the user for some input. So again, we can just use input brackets and then a string if we want to. So if I run this and I say, what's your name? Then I can type in Laura, because that is my name, and it'll output the answer of Laura. And we can actually we can set it equal to a variable. So here I've set it equal to name, and then we can print hello name. So let's do it again. So what's your name? Laura. Oh, I need to hit enter. And then it says hello Laura, which is a useful way to actually start building a chatbot or an interactive text game that you might want to use. Moving on to conditional statements. So this is if the conditions are met, let's do something. So this is when we start actually talking about coding logic and actually getting that into things. The first one I want to talk about is if statements. And if statements are very similar to the if function in a spreadsheet. So if you've ever used one of those, they shouldn't be that difficult for you. It tells the code if something is true, do something. And when I try to think about this in like a real world example, I kind of think about it, if you're going to make yourself a cup of tea or a cup of coffee, you might, in the UK, you might go over to the kettle, pick it up. If the kettle's full or has enough water in it, you'll turn it on. If it doesn't, you'll take it over to the tap and fill it up with water and then turn it on. So that's kind of some if logic if you're thinking about it. Maybe there's some good examples from your everyday life that you can use. And this is how it should be laid out. If condition blah, do something. If that was false, then we do this elif, which elif is very hard to say, which is if else or else if. So like if the first statement wasn't true, check if this statement was true, then do this, and we can end it with an else. So the only one you actually have to have is an if. So if something happens, do this. If you want to have just one condition, you can have an else. If you want to have multiple conditions, you can have an elif in the middle. So a very simple example, we have x equals 1. And I've said if x is greater than 7, print this is true. Else print this is false. Oh, sorry, print this is not true. So 1 is not greater than 7, so it's printed this is not true. But let's talk over what we've actually got here. So we've got this purple if, which we can see is a different color than everything else we've done before because it's one of the special words. We've then got this condition here. So this condition, basically what I would say is it has to have a true or false. It can't be something that can't be true or false. So it has to be something that the output of which will return a true or false. So it has to be a conditional statement. So it could be name equal Laura in quotation marks. It can't be name equal Laura in quotation marks because that would be the assignment, not the conditional statement. We then, when we're finished, add a colon and then take a new line. And this is quite important. So you notice there's a little tab here. So in Python, the tab and the lining things up is very important. The code will error. If I delete that, you notice this is all gone red. Expected indented block. So if I now run this, I'm going to get an error message saying we expected an indented block after the if. So you can get that by pressing tab, or if you type out the colon and then hit enter, it'll indent it for you. But what I think this is all the words in purple should line up. and then the next set should line up, and so on and so on. And then instead of putting an elif, we've just used one if statement, or sorry, one if statement and one else statement. We just type else and then the colon, and then we have what we want it to do, which in this case is just print this statement. So we can go on and write it with the elif statement. So if x is greater than 7, colon, new line, tab, do what you want to do. Else if x is greater than 3, so that'll be if x is between 3 and 7, else print x is less than 3. And it was 1, so it's less than 3. Combining our inputs and our if statements a little bit. So this is kind of a silly example. So I've said our answer is the response of this input, would you like to order a pizza? If the person says yes, so if answer equals yes, then we want to do another input. And I've been bad here. I've used one of the special words and I shouldn't do that. So I'm just going to very quickly fix that. You can see that's why it was green. So I'm just going to use an underscore and pizza. So this is something we call a snake case, just in case you're interested. So in Python, it's instead of having capital letters like you might have in other coding languages, we tend to use an underscore in between words and variable names and things. It's called snake case, which works because it's Python. I then am going to ask what type of pizza and what size of pizza, and then the final thing we're going to print out is what you've ordered. So as I said, a silly example, but let's have a go. So would you like to order a pizza? I'm going to say yes. What type of pizza? I'm vegetarian, so I'm going to say veggie, and I would like a large pizza. You have, I also should probably say you have ordered a large veggie pizza. And I'll just run this again just to show you. So would you like to order a pizza? Yes. Nothing happened. So what's different this time? If you spotted it, it's actually the capitalization of the word yes. So the answer is particularly looking for yes with a capital. But what we can do is add in or answer equals yes with a small letter. So let's try that again. Run. Would you like to order a pizza? Yes. Type of pizza, let's say hot. And let's say small, because this one's just for me. You have ordered a small hot pizza. Yay! Okay. There are more advanced ways to do that, but just to show you, you can have more than one condition. So we can have ands, where both conditions have to be true, or ors, where one or the other condition has to be true. So we can use those whenever we're writing if statements or other conditional statements like the ones we're going to go on to next. We have some other conditional statements that are called while and for loops. And what that means is the code will do something until a condition is met or a certain number of times. So let's say we want to just print out some numbers. Very, very not super useful, but let's just do it. So we've got x equals 0, while x is less than 10, print x. And then we say x equals x plus 1. So if we run this, it prints out the numbers from 0 to 9. Be very careful, because if I comment this out, and you can comment by clicking on the end of the line and then doing Control or Command, so if you're on Windows or Mac, and / comments it out for us. But if I don't have this line in, this will run forever because we're not actually changing x, so x is always under 10. And just to note, if you do ever do anything like that, you can just click the stop button and it'll stop running. And then I can add this line back in and rerun it. So while x is less than 10, print from 0 to 9. So because it's less than 10 and not less than equal to 10, it stops at 9. And it adds 1 every time. If we wanted to print on the even numbers, we could do add 2, and then it'll print out 0, 2, 4, 6, but 8, but again, because it's less than 10, it'll stop. So these are while loops. So you probably want to do that while, like if you want something to keep going until a certain condition is met. So it might be if you're adding numbers to something and you want it to stop at a certain point or something like that. If you want to do something else, so you want it to do something a set number of times, you can use a for loop. So a for loop in this one, we've said for x in the range 2 to 10, print x. So we've got 2, 3, 4, 5, 6, 7, 8, 9. Again, so think about this. The last number is a less than. So to me, it seems like it should include 10. So it's in the range 2 to 10, but it doesn't. It means the same as this. So while x is less than 10, we can also add in this one a step change, it's called. So if I want it to go in increments of 2, so 2, 4, 6, 8, I can obviously make this step change smaller than 1 if I want to. So I can make it 0.5 if I happen to want to, and it'll go up. Ooh. So here we go. This is an interesting one to see. So a float cannot be interpreted as an integer. Ooh, what is the problem here? Let's have a look. And let me see, I'm going to try and debug on the spot. No. Okay, this is a great lesson in debugging, like a live one. So if I was trying to debug this and I didn't understand it, I would copy and paste this line into Google. Paste it in, have a look. So type error float cannot be interpreted. Stack Overflow is a good and trustworthy website that I typically use. I normally skim, okay, and see. You're creating a float. You need to use the division. Okay, range can only work with integers. That's my bad. So I thought so. Then we're going to have a think about what we want to do. So I want to do range, Python, step, float. There we go. Other people have done it. So how do I use a decimal step value for a range? And let's have a quick look. Yep, so they've tried to do exactly what I've tried to do. They want to go from 0 to 1 in increments of 0.1, and they've gotten this error. Ooh, and we're being told to do something a bit more complicated. Okay, so we'll just leave that for now. But this was just me trying to show you that we can actually work out how to do things just by doing some Googling if we want to. Why we're going to leave that is because we have to import other libraries and we aren't covering this in our very quick introduction. So let me go back and we'll make this go up in 2. There we go. Yay, no errors. That's good. We've covered quite a lot in this Whirlwind introduction to Python. This is the first part of the introduction. We have covered data types, thinking about using comments, how to use variables, and then how to do lots of printing so you can see the output of what you're doing. And then we moved on to the conditional statements, if statements, for loops, and while loops. I think that's a great introduction to Python. And if you want to learn some more on any of these particular topics or more on Python in general, we do have some great resources on those.